Welcome to Signals and System subject classes. So this is the sixth video. We are in the first chapter, that is the basics of the signals and system. In this class, we are going to discuss system properties. That is the first one, system with memory and without memory. Without memory. In general system definition, in the block diagram, so this is the block diagram for any system. So this is a system. So this is the input. So this is the output. So the system definition is nothing but it is a group of components that act according to the set of rules. In mathematical, y of t a into x of t. It's a general, or plus b into x of t minus 1. So here the system, it is defined by the input and output relationship. So is general system representation. So now in this topic, we're discussing properties. The first one is system with memory and memoryless. I'm going to explain the system without memory. So that is A, memoryless. See, this memoryless, it's a simple definition. The output, say in memoryless system, the output depending on the input at the present time only. Is it? In the definition, a system is said to be memoryless. If its output for each value of the independent variable, at a given time is the memoryless, its output some independent variable at given time is dependent only on the input at the same time, at that same time. It means the output shouldn't depends on the input at the future values, is it? The output must be depends on the input at the same time. Example, see the y of t equal to something x of t in case of continuous. In case of discrete, y of n equal to x of n. These are examples. Another one, y of n equal to 2x of n minus x square of n. So this output, it is depending on the input at the same time. There is no future values. There is no n minus 1 or n plus 1, is it? The output, it is depending on the input at the same time. So for example, we know I am going to write the voltage and current relation in the resistor. So V of t equal to resistor R into I of t. This is our register component. I of t we are assuming the input, so V of t is the output. See this V of t, it is depending on the input at the same time, is it? So here R we can say memoryless system. So now memory system. In definition, a system having memory if the current output is dependent on future values of the input and output. On future values of the input and output. Example, see, for example, one system mathematical expression is like this: y of t equal to a into x of t plus b into x of t plus 1. Substitute t equal 0. So y of 0, for example, t equal 0, I am assuming. So this t equal 0, this is 10 a.m. For example, 10 a.m. Is it? So output at 10 a.m. that equal to a into x of 0. The input also at the 10 a.m. b into x of 1. This is 11 a.m. So the output is depending on the future value, is it? So the system can be called as a memory system. In discrete, we can write y of n equal to. So this is output. It is depending on the in delay x of n minus 1. So this is the one examples. This is the second in discrete. Similarly, we can write y of n equal to sigma x of m, so m minus infinity to n. So for example, if this y of n, this is unit step, and x of m it is a impulse, is it? We know that relationship between the unit step and impulse. So I am taking the impulse signal as a input and a unit step as a output, is it? So we can also write like this. X of n minus k from 0 to infinity, is it? So this is a x of n is input, y of n is the output, is it? Here y of n so the y of n output is depending on the all delay input signals, is it? So this is memory system. Memory system. Similarly, we can, I'm taking the capacitor. The output V of t equal to 1 by C integral minus infinity to t x of tau into d tau. So it's like not x of tau, current. So for example, so this is a capacitor. This is the output, input current. So this is capacitor. So voltage drop across the instantaneous so this is a capacitor. Memory system. This is capacitor. Already we have discussed this relation u of t equal to integral minus infinity to t del of tau into d tau, is it? Same, similar to same discrete, is it? So here we're taking del of t as a input, unit step as a output, is it? So V of t, voltage and current. Same similarly, we can write same for the inductor. I of t equal to 1 by L integral minus infinity to t V tau into d tau. Is it? That is also memory system inductor. The next property, invertibility and inverse system. So I'm going to explain with the help of the block diagram. So this is the one system. For example, this is a x of t, x of t. So it generate the y of t. If I design the one system to generate the same, which is taking the y of t as the input, and if it can able to the generate the output as a x of t, for the second system, y of t is the input. So this is z of t is the output of the second system. See here, two systems are connected in cascade. So this is the first. This is the first input, first system. For the system, input is x of t and y of t is output. The second for y of t is the input and z of t is the output. For example, I'm taking simple example. For example, this y of t is a relation y. So y of t equal to multiplication. So 2 into x of t. Is it so? So this system is a multiplication, multiplier. The coefficient equal to 2, is it? So y of t just 2 is multiplied by the x of t, is it? So if I generate, so here I have given the x of t. If I design the one another system, that system is if it able to the generate the same x of t, then the system is, we can say that this is the inverse system to this system. For example, so I have given the x of t, so y of t, here I got the 2 into x of t. So again, when will I get the x of t? For the division, is it? So simple. So y of 2 into y of t, so 1 by 2 into y of t. It is a relation between the input and output of the second system, is it? So y of t equal to 2 into x of t, 2 gets cancelled. Again, we can able to get the x of t, is it? So this system, it is called inverse system, is it? The second one is inverse system. So this system having the inverse system, so then we can say that this system is following the invertibility property, is it? So, what is the definition? A system said to be invertible if distinct input leads to the distinct outputs. Distinct inputs leads distinct output. See, to check the whether the system is a invertible system or not. For example, if you have given the, for example, here in the second case, so this is x of t, this is y of t. So y of t, I'm going to write the relation. So y of t, it is equal to the square of the input. So x square of t, is it? So for the definition, so a system is said to be invertible if distinct input leads to the distinct output. For example, I'm taking x of t equal to, so here, so in example x of 2 equal to, I'm taking 2, the corresponding output I will get the value equal to 4, is it? Based on the expression, is it? Again, I'm taking x of 2, this is x1, this is y1. So in second case, x2 of t equal to, I'm taking minus 2. is it? But even though I'm taking the different input values, but here I'm getting the same output, is it? So from the definition, distinct input leads to the distinct output. So here we are taking the different inputs values 2 and minus 2. Even though we are taking the different values, but we are getting the same outputs, is it? So it is not the invertible system, is it? Coming to the discrete time, I'm drawing the one block diagram. In discrete, so this is x of n input and y of n. So here I'm taking the relation, this summation relation, is it? So we know that, so y of n in summation, y of n equal to sigma x of m from minus infinity to n, is it? So this is a summation, is it? Then the inverse system must be differencing, is it? So that is output of the second one is w of n, is it? So the wn must be is equal to y of n differentiating y of n minus y of n minus 1. Same, we have discussed in the previous video relationship between the unit step and unit impulse signal. So this is the summation. So the summation so this inverse system must be differencing, is it? The third property is causality. See, in causality, the output must be dependent on the input, present and past. Simple thing. So, a system is causal if the output at any time depends only on values of the input at the present time and the past. At the present time and in the past. Past, not present. So here I am underlying. See, the output is it must be depends on the input at present and past. Example. So this y of t a into x of t minus 1. Check it. For example, t equal to for example 10 a.m. Then so y of that equal to 0. Is it? So 0. I'm taking t equal 0. So a into x of minus 1. If you assume that 0 is a 10 a.m., so y of 0, so y is depending on the 10 a.m. and sorry, this y of output it is at the 10 a.m. that is depending on the x of minus 1. So minus 1 is nothing but 9 a.m. So this output is depending on the past input. Is it? This is one example. The second one, so for example, y of t plus 1 that equal to a into x of t plus b into x of t plus 1. substitute t equal 0, so y of 1 equal to a of x of 0 plus b x of 1, is it? In this case also output depending on the input at present time and past value, is it? So both are causal systems. Now in third example, so y of t equal to a into x of t minus 1 plus b into x of t plus 2. This output, it is depending on the past input and future input, is it? Substitute t equal 0, so x of minus 1, it's a past value, and x of 2, this is a future value. So this is non-causal system. Non-causal system. Another example, I am taking in discrete, so y of n equal to x of minus n, is it? At t equal 0, it satisfies the output depending on the present input. See, at t equal 0, so y of 0 that equal to x of 0, is it? So it's satisfying the definition. For the positive value, for example, I'm taking positive value, so plus 1. For that, so y of 1 equal to x of minus 1, is it? So output depending on the past value of the input, is it? Now in third case, I'm taking now t equal to minus 1. For that, so y of minus 1 that equal to x of 1, is it? So the output depending on the future value of input, is it? Then it is not causal system, it is a non-causal system. So to check the causality, you should take the all values negative. So you have to check it for the positive values, for the negative values, is it? So this is non-causal. So it's a very, very important problem. Next, fifth example. See, so y of t equal to x of t into cos of t plus 1, is it? So this is t plus 1 is the future value, is it? So this is the output, this is the input, this cos of t plus 1 is the coefficient, is it? So in this case, it look like a non-causal system. That is, this t plus 1 is the future value. But this is a causal system. Why? Because the output is depending on the input at present time only. This is the coefficient, it is not the input, is it? So this is the output, this is the input, is it? You should concentrate on output and input. So this is the coefficient only. It doesn't matter whether it is a cos of t plus 1 or t minus 1. It doesn't matter. It never affects the causality, is it? You should always focus on the input and output, present and past and future values, is it? So this is causal system. So it is also important problem. So there is a input and this is the coefficient. So it is about causality, checking, is it? Then we will discuss remaining 3 properties in the next class. Thank you.